So let's try to solve an equation with radical expressions like this. So if I give you the square root of x squared minus 4x minus 1 plus 3 is equal to x, and I want you to solve for x. That is, I want x, the end result should be x is equal to some sort of number. So now I want you to note that there's only one square root in the whole thing, and since we know that we're going to end up squaring both sides, the first thing to do is to make sure that everything belonging to the radical sign is on one side and everything not belonging to the radical sign is on the other. In this case, since this positive 3 is not inside the radical, we want to subtract it from each side of the equation. So now our equation looks like x squared minus 4x minus 1 square root equals x minus 3. So now we want to apply the squaring property. So we want to square both sides of the equation. Now on the left side, the square is going to cancel out with the square root. So we're just going to be left with the radicand. So we get x squared minus 4x minus 1 to one side. Whereas on the right side, we're actually going to end up getting like how we FOIL. So this is going to become, x minus 3 times x minus 3, which I'm just using the definition of squared, which is you multiply what you're squaring by itself. So with this, you can FOIL out to get the result. So let's FOIL this out. The first term is going to give us x squared. The outer term is going to give us minus 3x. So is the inner term. And then the last term is going to give us plus 9. So now, let's just simplify. Down here we can combine this to become minus 6x. So let's just rewrite it and do that. So x squared minus 4x minus 1 is equal to x squared minus 6x plus 9. So now what we want to do is to move everything to one side of the equation and have it equal to 0. So let's subtract, let's use green, subtracting x squared from each side. And in this case, on both sides, the x squareds cancel out. So let's rewrite this again. We get minus 4x minus 1 is equal to minus 6x plus 9. And now since we want to solve for x, this actually becomes a lot easier, because now we just move everything with the x's to one side and everything not with the x's to the other side. So in this case, we would add 6x to both sides, and then we would add plus 1 to both sides. So invariably on the right side of the equation we'd have no x terms, and on the left side of the equation we would have no constant terms. So doing that, 6x minus 4x is going to become 2x, and then 9 plus 1 on the right side is going to become 10, which means that x is equal to 5. So that's our solution. But since we ended up squaring both sides of the equation at the very beginning, right here, we want to check to make sure that our solution actually works. And this is what you do every time you square an equation. So the way we do that is by plugging in x is equal to 5 into the original equation. So the original equation was square root of x squared minus 4x minus 1 plus 3 is equal to x. So now replacing all the x's with 2 to 5's, we got 5 square root of 5 squared minus 4. Ooh, that did not look like a 5 at all. Minus 4 times 5 minus 1 plus 3, and we want to see if that's equal to 5. And the way we show that we're just checking is by putting a little question mark over the equal sign. So simplifying this further, this becomes square root of 25 minus 20 minus 1 plus 3. We want to see if that's equal to 5. So 25 minus 20 minus 1 is just 4. Plus 3. We want to see if that's equal to 5. Square root of 4 is 2 plus 3. and we want to check if that's equal to 5, and 2 plus 3, as it turns out, is 5. So the left and the right hand sides of the equation agree, which means that x is equal to 5 is a solution. So the solution is x is equal to 5. You can write that down, or, depends on what your instructor wants. You can just leave this circled. But yes, you want to signify that the solution checks out.